Hello there, welcome to this channel. It's been quite long since I did my last video, and I hope I'm here to stay. All right, I'm back with matrices. I do remember doing a video on matrices, but I don't know. Okay, this one will be a bit different. It will be matrices at senior level. Now, of interest, I got attention of this question under matrices, because we know, of course, that it's always row by column, especially when you're multiplying matrices. And of course, following the Zambian syllabus at grade 12, there is always where they will be you'll be asked for a transpose of a matrix, of which is just a walkover to most of us. And of course, there is also a part where you're told to find the value of the unknown, and then there's a good explanation that will help you to find that unknown. For example, they'll say find the value of x if the determinant is this, or find the value of x if this matrix has no inverse. Of course, you know that if that does not inverse, it means that the determinant, of course, is 0. So now this one was quite different. Of course, okay, just look at the whole question first of all. So given that matrix 4, come on, given that matrix A is 4, 5, 1, 1, and B is x minus 1, then 1, 2, then 0. Find A transpose. Now, when you transpose the matrix, of course, you know that a matrix is always an array of numbers presented in rows and columns. So the rows, these are not vertical, horizontal, yeah. And then the columns are vertical. So when you say you have to transpose the matrix, it means that those entries that were in a row, you should arrange them in a column, or let me use this word, those elements that, or those entries that were horizontal, you are going to arrange them as vertical, and of course those who were vertical as columns. For example, so they're saying find the A transpose. First of all, matrix A. Okay, let me write little solution there. Solution. Okay, there's N there, no problem. Then we have A, matrix A, which is 4, 5, 1, 1. Yeah, this is A, and like so A transpose is equal to, if you look at the row here, there was 4 and 5 in the first row, and then of course the second row there was 1 and 1. So what they're trying to say is that arrange these numbers not as horizontal as they are, but as vertical. So we're going to have the first entry there to be 4, and then 5 will be somewhere there down, so that it becomes like, yeah, a column, not like a column, but it becomes like, I'm using like again, it becomes a column. Then we have another 1 there, and again 1 down there. Imagine, we're done, just like that. You earn yourself a 1 mark, I think. Yeah, okay. As motivation, you earn yourself 1 mark. So you have 99% to go, of which there's another one there that says find the value of x if AB is equal to 10, 2, 4, 1. So how do we do this? How do we do this? Now, if you look at AB, if you look at the matrix B the way it is, x minus 1, 1, 2, 0. So what we want to do is this. We're going to multiply these matrices, and then we're going to equate them to 4, 1, 5, not 4, 1, yeah, 10, 4, and then 2, 1. So we're going to have AB. First we'll say A, or this was 2. A, that is times B, is equal to what? We have 10, 4, then we have 2, 1, like this. So let's go ahead and write matrix A there. Matrix A was 4, 5, then 1, 1, times how B was 1, negative 1, then 1 here, 2, then 0, then is equal to, what is the answer we're given? I said it is 10, 4, 2, 1, like that. So you know how we do of course, how we multiply matrices, it always row by column. So as it stands, I don't think we're going to finish like doing this one, that one, again this one with this one, this one again, like that. But we're going to consider those that are going to use x as a value. So we'll start with this one first of all. 4 times the whole of this entry here, because that's how we multiply matrices, isn't it? We say this one times this one plus this one times this one, again this one times this one plus this one times this one. So evidently we're not going to consider these one, because what we're interested in are these values here, where there's x, of course. So we're going to have this something like this: 4 times this one. Let me just go direct. 4 times x minus 1, it will be 4x minus 4. Yeah, 4 times x, that is 4x. 4 times negative 1, that's negative 4. Then plus 5 times 2, yeah, that is 10, right? 10. Then would have gone this side, but it is a waste of time, because what we're interested in is the values that have x, because when we say 4 times 1, 5 times 0, we're not going to find x there, so let's just leave it like that. So then let's come down, because even this side has to be multiplied by this part here. So we're going to have 1 times 1 minus 1 times x minus 1, it would be x minus 1. Then 1 times 2 there, okay, plus 2. Now have you noticed that when we find the value for this one, this equation represents this entry which is here, and so does this one here, representing 2 there. So let us go ahead and equate this one to these their values, because when we're supposed, if we had done this and this one, or this one also with this one, would have found these values here, but this one we're interested in the first part here. So this one is going to be equal to what? To 10. So, and then this one is equal to the 2 that is here. So we have now we have 4x there. Yeah, I think this one is giving me positive 6. Yeah, is equal to 10. Then this one, I'm going to have x there. This one will give me, is it positive 1, is equal to the 2 that is there. Oof, I have 2 equations here. Let's do a little simultaneous equation here. How? Simultaneous equation, isn't it? And I remember teaching my student where I said if the signs are the same of the value that you want, you are going to multiply those ones, isn't it? So this one are going to have something like 4x plus x, that's 5x. Then this one 6 plus 1, that is 7, is equal to 10 plus 2, that is 12, like that. Then you're going to have we correct the like terms. It will be 5x is equal to 12 minus 7. Yeah, this one goes there. Yeah, those are basics, you know. Ooh, I'm running out of time. Okay, then this one. Okay, so this one will give us 5, right? So yeah, so we're going to have something like x is equal to 1. I'm saying 1 because when we simplify on top there, we're going to have something like 5. Yeah, 12 minus 5 is what? 12 minus 7, rather, it's 5. And then, so this is it. So remember what we did? We just wrote them in matrix format so that we can do the normal multiplication of matrices row by column, and we only focus on those entries that have x in it, like this one and this column, also this row and this column. Then we ended up having something like a simultaneous equation. Then we did add these two to give us something like this, and then our final answer is 1. Yeah, so that's it. Comment what you think about this video, and please motivate me to continue coming with these videos. By motivating, I mean share. Yeah, share, like, comment. Yeah, until next time, bingo.